I'm presenting a problem about understanding the output of scikit-learn's "enet_path" function, which is used for finding the regularization path of an elastic net model. We'll focus on interpreting the shapes of the output arrays. Key to solving this is understanding what regularization, elastic net, and a regularization path are. This statement is true. I see that the "cofs" array has a shape of 10, 5. The first dimension, 10, represents the number of features in your dataset. This is also true. The "alphas" array has a shape of 5. This tells me that 5 different alpha values, regularization parameters, were used. Yep, true again. In the 10, 5, "cofs" array, each of the 10 rows represents a different feature. Each of the 5 columns shows how the coefficient for that feature changes as the alpha value changes. And finally, another true statement. The "enet_path" function usually returns alpha values in decreasing order. This means the first column of "cofs" shows the coefficients when alpha is at its highest value. This is the core problem. I'm given information about the shapes of the output arrays from the "enet_path" function. I need to use this information to interpret the results and answer the following multiple choice questions. Enet stands for elastic net, a type of regression. The regularization path shows how the coefficients of a model change with different levels of regularization. This section is a heading and isn't directly explained in this particular section of the text. This section provides further information in a concise form. It reinforces that each row in the 10 by 5 "cofs" matrix corresponds to a different feature. This is crucial for understanding the relationship between the dimensions of the array and the characteristics of the data. This phrase simply means we're figuring out how different amounts of regularization affect the elastic net model. Elastic net is a type of regression that combines L1 and L2 regularization to prevent overfitting. The regularization path shows how the model's coefficients change as we adjust the regularization strength. Think of it like this. Imagine you're tuning a radio. The regularization strength is the dial, and the coefficients are the sound. As you adjust the dial, the sound quality, model's performance, changes, and this is what the interpretation focuses on. This tells us the shape of a matrix called "cofs". It has 10 rows and 5 columns. In our case, each row represents a feature in the dataset, so there are 10 features, and each column shows the coefficient values for that feature, but at a different level of regularization strength. Imagine a spreadsheet. Each row is a different ingredient in a recipe, and each column is a different amount of spice added. As you increase the spice, the flavor, and model performance changes for each ingredient. I see that the number of rows in the "cofs" matrix, 10, directly tells us the number of features in the dataset. This makes perfect sense because each row represents a different feature's coefficients across all regularization strengths. The "alphas" array is one-dimensional, it only has one dimension, and contains 5 values. Each value represents a specific regularization strength in the elastic net model. Think of it like tuning a knob that controls how much you penalize complex models. The length of the "alphas" array, 5, tells us the number of different regularization strengths that were used in the analysis. Each of the 5 values represents a separate level of this regularization strength. This question focuses on understanding the output of scikit-learn's "enet_path" function, specifically how the dimensions of the arrays relate to the number of features and regularization parameters. I'll be explaining the meaning of the dimensions of the coefficient matrix and the regularization path. It's all about interpreting the results, not performing calculations. Get ready to learn. We're given that "cofs" is a 10 by 5 matrix and "alphas" is a 5-element vector. This tells us a lot about the elastic net model's results. The dimensions of these arrays contain all the information we need for interpretation. It's like a puzzle where the shape of the pieces gives us the big picture. I see that "alphas" has a shape of 5. This means there are 5 different values of alpha, which is the regularization parameter used. Each alpha represents a different level of regularization strength applied to the elastic net model. More alpha means more regularization. The COFS matrix has a shape of 10, 5. I observe that the number of rows, 10, directly corresponds to the number of features in the dataset. Each row represents the coefficients for a single feature. It's a neat way to see how many variables the model considers. Looking at COFS 10, 5, again, I see each row represents a different feature. Across the 5 columns, you see how the coefficient for that single feature changes with different alpha values. Think of it as a profile of how each feature's importance shifts with regularization. I notice that enet_path usually outputs alphas in decreasing order. That means the very first column in COFS reflects the coefficients when the highest alpha, strongest regularization, was used. It shows the coefficients after the heaviest shrinkage. I interpret this as understanding how the results from an elastic net model, specifically the regularization path, are presented and what they mean. The elastic net combines L1 and L2 regularization to improve model prediction accuracy and prevent overfitting. The regularization path shows how the model coefficients change as we adjust the regularization strength. We are given that COFS, a matrix of model coefficients, has 10 rows and 5 columns. Alphas, a vector of regularization parameters, has 5 values. The dimensions are key to interpreting the results. I see this as true. The number of rows in COFS, 10, represents the number of features in the dataset used to train the elastic net model. Each row corresponds to a feature's coefficients. This is also true. The length of alphas, 5, tells us 5 different regularization strengths. Alpha values were tested. Alpha controls the amount of regularization. Absolutely true. Each row in COFS shows how one particular feature's coefficient changes as alpha, regularization strength, varies. You could plot these and see the coefficient path for each feature. Correct. The enet_path function usually orders alphas from largest to smallest. Therefore, the first column of COFS represents the model coefficients when the strongest regularization, largest alpha, is applied. This tells us the shape of the coefficient matrix. It's a 10 by 5 matrix, meaning I have 10 rows and 5 columns. Each row represents a feature in my dataset, and each column represents the coefficients for a different value of alpha, the regularization parameter. This shows the shape of the alpha vector. It's a one-dimensional array with 5 elements. Each element represents a different strength of regularization. Scikit-learn's enet_path function typically lists these in descending order, starting with the strongest regularization. I have 10 features in my dataset. This comes directly from the number of rows in the COFS matrix. 10 rows means 10 features. It's that simple. The number 5 represents the number of different alpha values tested. I found this by looking at the length of the alphas vector, which has 5 alpha values. This statement is true because, as I explained earlier, the number of rows in COFS corresponds to the number of features in the dataset. Correct. The length of alphas tells me there were 5 alpha values used in the regularization path. Absolutely. Each row of COFS shows how the coefficient for a single feature changes as I vary the alpha value. That's right. Remember that enet_path usually orders alphas from largest to smallest. Therefore, the first column of COFS holds the coefficients calculated with the largest alpha value. This is the title of the problem. We're going to interpret the results of an elastic net regularization path, which is a way to find the best balance between model simplicity and accuracy. Here's the crucial information. COFS is a 10 by 5 matrix of coefficients, and alphas is a vector of 5 alpha values. These are the outputs from the enet_path function. We'll use this information to answer the multiple choice questions. I see 10 rows in the COFS matrix. Each row represents a feature in the dataset. Therefore, there are 10 features in total. I notice 5 columns in the COFS matrix. Also, alphas has a length of 5. This means 5 different values of the regularization parameter alpha were used. Alpha controls the strength of regularization. This statement is true because the number of rows in cofs 10 matches the number of features in the dataset. Each row corresponds to a different feature. This is true. The number of columns in cofs 5 and the length of alphas 5 both indicate that 5 different values of alpha were used in the analysis. This is true. Each row shows how the coefficient of that particular feature changes as alpha changes. This is also true. The enetpath function usually returns alpha values in descending order, so the first column shows the coefficients for the largest alpha.